Hi, everyone. Welcome to the session 9 of the project management training series. So let's dive in. In session 9, we are going to talk about time. So if you remember, the triangle or the triple constraints of project management, we have got scope, time, and cost, and in between we have got quality. Now, in the planning stage, we already have gone through in detail about scope, and we have derived the scope baseline. We have also created the WBS and the WBS dictionary. And now is the time to develop the schedule baseline. So looking into time, we are going to talk about multiple things like dependencies. We are going to talk about activities and how to sequence them, right? Then we are going to talk about network diagrams, one of the most critical elements of schedule management. And if you are planning to crack your PMP exam, be ensured that you must master network diagram questions. The more you are good in developing the network diagrams by looking at a chart, the more easy for you will be for you to crack the exams in the question in a very short amount of time. And these are pretty much easy. Like now we are in the stage where it's all pure mathematics. Okay, the activities, the network diagram, the dependencies, it's all pure maths. And finally, develop the network diagram. Now, network diagram can definitely be developed with the help of project management software. You can pick up any standard PM tool, let's say Microsoft Project, and it's very simple. If you just plug in the activities and if you just plug in the predecessor or the dependencies there, it's very simple for the software to show you the complete the network diagram there. But looking for the PMP exam certification, it's expected that as a PM, you should be able to formulate and calculate a network diagram on a piece of paper. Like, if you have gone to the CCNA, we all know that there are pretty good subnet calculators, and you can just punch in the kind of the IP address and the groups which you need, and you click on the buttons and you get the complete subnets and you derive the host and the IPs. But as a network professional, you have to know how to calculate the subnets, right? So that's why the CCNA exam also gives you questions on subnets and IPs and expects you to derive the host, the number of hosts and all that stuff without using a calculator. Similarly, for network diagram also, it's quite fun, quite simple to go ahead and to plant a network diagram on a piece of paper and then derive multiple important critical stuff from the network diagram. So let's dive in. First thing first, time or schedule. So let's talk about the planning stage. So planning stage till now, what we have completed how to derive the scope baseline and how to develop the WBS, how to create the WBS dictionary. Now, everything which is coming in the first statement, like in the bullet points, the first one text is in black color because that is something in the past we have already done that. Now, all the items in the bullet which are in red color, those are the fun and the cool things which are we going to do in the planning of the schedule. Okay, and we are not going to do them all of them in this particular lesson 9 itself. I think that will be too much for you to absorb. We are going to do a couple of them. We are going to leave out the critical path in the schedule for the upcoming lessons. So first one is about to define the activities. Now, if you remember, when we were doing the WBS, we said these are the work packages which are being linked to a control account, okay, to monitor them. But these are not the activities which are in reality to be done in the ground level. So these are the big, fat, packages which has to be broken down into multiple activities to be done. Now, once you create or define the activities, which we are going to see like very soon, you have to actually jot down the list of the activities, say 1, 2, 3, 4, 5, 6, right? Now, once you list down the list of the activities or the group of the activities which you are going to perform, then always know that in a project, you can either do the activities or execute the activities in sequence, or you can do them in parallel. There is no other way to do it, right? Either the sequence means that one activity has got a dependency on the previous one. So let's say I've got 3 activities A, B, C. Maybe the activity A, I'm going to, let's say, build a wall, okay, like construct a wall. And activity B can be to paint the wall. Now, activity B can only be done when the wall is being constructed, right? I mean, I cannot pay, I can't even think about like painting a wall if the wall itself is not, constructed, right? So activity B has got a dependency on A. Okay, and that's why we will do A and then after that B, right? And maybe your activity C is something which can be done in parallel. Okay, maybe what you are going to do in the future, maybe you're going to hang some pictures on the wall, and for the pictures you probably have to do some designing of that, or you have to pick up some old pics from your album and find it out or collect it or keep it in a place, right? Now that all can be done in parallel while the wall is getting constructed by the men. One of the guys in the team can actually start choosing the pictures that they are going to hang on the wall, right? So that activity can be done in parallel. So sequencing the activities, and once you sequence the activities, once you know that what comes after, then that itself is called a network diagram. Then you will be creating a network diagram. A network diagram, it's a visual representation of all the activities from start till end of the project, and you can very nicely see that which activities can be done in sequence and which can be done in parallel. Okay. Now, once you are going through the network diagram, it's very, very simple to know that if my one activity takes, let's say, 10 hours, then how many resource or man hours I need there. So man hour can be 10, probably one guy can do it in 7 days, or two guys can do it in 3 days, and so on, right? It depends on how much fast you want to do it. So probably you want to plug in two guys there, or maybe one guy for 10 days. So basically, you are finding out, or you're estimating the requirements of the resource once you draw the network diagram. That's the beauty. And then, of course, the durations of each of the activity, the time part can be plugged in as well. Finally, looking at the activity, you will be knowing, or looking at the network diagram, you'll be knowing like what is the critical path. Now, what exactly is a critical path? I'm not going to talk about it right now. That is a concept to be shared in detail in lesson 10. But just know that the critical path is a very easy concept, but it's not exactly what you think, or it's not exactly what people keep on talking in every meeting, like we are hitting the critical path, we are hitting the critical path. It may not be the thing which you probably would have assumed, because many people they wrongly interpret the critical path, because they are thinking the critical path meaning as in plain and simple English. So they kind of think that whatever is critical activity in a project, that is in a critical path. That is not true. Actually, there is a particular way to say which items are falling in critical path, and that's a pure mathematical way, and I will show it to you. Okay. And finally, once all this is done, then you develop the schedule of the project. Now, the last item in the bullet list is develop the budget. That's again in black color, because that's not a part of your time thing. But you will see when we are getting into like developing the budget, it's like one single stage, right? We are not doing all these things. So like I said, if your scope is crystal clear and you have done good work in the scope and the baseline is correct, right, along with your WBS and your dictionary, and depending on that scope, when you pull out the activities, you draw the network diagram, you find the critical path, you draw the schedule baseline, immediately your development or the build-up or the creation of the budget or the cost will be very simple, because you already know how many resources you need to complete this particular activity. Now, when you add up those time frames, those durations, you will be going to reach a number of hours, or number of like total man hours which you need on the project. And again, the man hours, that the cost of it, the cost of the resource per hour or per week or per day or per month. And immediately, very quickly, you can find out what is the total man hour cost for this project. And with that, you just have to add the additional hardware or any other sub project which you are doing to complete this project. Now, once you add up the hardware cost and the man hour cost, you definitely will lead to the cost of the project. So the services and the cost of the hardware, right? So developing the budget will not take too much of time. It will be very simple if your schedule has been done in a very nice way. All right. So let's talk about dependencies. Before I get into the activity list and show you, let's talk about the various kind of the dependencies, because that will be a very frequently kind of used term by myself going forward. So it's good to have a very clear clarity on the types of the various kinds of the dependencies in a project. So dependencies from the exam point of view also, it's very nice to know this, because it's a very, sometimes the questions are like very simple, but you have to know the difference between the dependencies that's been talked on the use case. So dependencies are of four types. The first one is mandatory, which is hard logic. Okay. Now mandatory means that this is a must dependency. You cannot bend that. You can't change that. Okay. So let's say that from the CIB point of view, right? Your hardware, okay, which is shipped onto the site, that must be rack stacked or mounted on the racks before even you think about you know uh, doing the configuration or plugging in the deployment configuration, right? So that's a must. Without even racking, stacking the devices or powering them on, you will not be able to like proceed with the next step, right? Now, discretionary dependency is something which is preferred as per the org, or as per this current team or the project lead. It's a preferred way. We call it soft logic, which means that, let's say, the discretionary dependency is the coding has to be completed before the testing starts. Okay, now that's not always true. Okay, now these days, most of the testing happens while the coding is going on, which means that the coding don't have to really complete 100%. Probably once the coding has started and reached like 10% or 20%, at that point of time, the testing can simultaneously start off with the existing code. And why this is done? To save time, to ensure that at the end of the complete coding, they don't have to reinvent the code, or they don't have to scratch it off completely and then do it again, right? So we call it dynamic testing, and that's one of the most use cases which is being used these days to ensure that the time is being saved. So this is not a very true statement, but yes, it depends from org to org, from company to company. Some company might believe that no, we are going to complete coding first and finish it off till the dotted line, and then we are going to touch the testing. It depends, right? But it can be changed if the need comes. Let's say you have to play with some of the activities, that okay, this activity cannot be in sequence, that can be done in parallel to save some time. Then you definitely can change the logic or change the dependency in this case, but definitely after you talk with your program manager, right? And the last two kinds of the dependencies are external and internal. So external is something where the dependency is with an external supplier, or maybe some regulatory body or something, like let's say customs, right? When your hardware is coming to another country, like let's say from Singapore to India, it hits the India port, and the customs at that particular port has to clear off the devices as per the local regulations, and then and only then the devices will be going by transport from the port to the site. Now, if there is a delay by customs, or if some like devices has come which are a kind of a prohibition, or which are under red flag for the local laws, then it will take, the custom will not clear them, or they will be asking you more questions, and you have to be ready with the answers. So external dependencies has to be given some kind of buffer. You cannot plan them with a strict timeline, because they are not in your control always, right? So keep some timelines, keep some more like days to them. But sometimes if you look into the past historical record of the project, let's say similar kind of projects done by the company in the past, then you will be getting a kind of a historical or a kind of a heuristic view of timeline. Okay, this is supposed to be done in 20 days or 3 weeks, something like that. Internal is something which is again a dependency, but that can be managed by the org internally. So when you look into, let's say, the network diagram of the project, and you see that, okay, this one activity is like 40 hours of work, and the remaining is like only 5 hours of work. But this one, we need the maximum hands on the table. And if you want to complete this on right time, we probably have to pull in some resources from some other projects in the company. Some sharing has to be done, because just for this activity, we are not going to hire some new guy, because we will not be having some work after this activity is completed. Then what will that new guy do, right? So we will not go to the finance team asking for a new hire rec just for this activity. Rather, we can use the existing resources from some other orgs who are kind of fluent with this kind of projects, and they can contribute. So these are the four types of dependencies which you normally see in a project timeline. Now, when you talk about the PMP exam, the most of the dependencies in the exam will be mandatory. Okay, hard coded or hard logic. Okay, the discretionary also is planted once in a while in a very tricky way, and you have to look at the use case to find out which is the discretionary dependency they're talking about. But when they ask you to develop a network diagram, or let's say they give you a list of activities and ask you to find a critical path. Now, in that case, if not stated, then you always have to assume that they are talking about mandatory dependencies between the activities. Okay, now let's move forward with activity list with dependencies. Now, spoken a lot, right? We have spoken about till the work package. Now let's see how the activity list is being done. It can be done in a very simple way on Excel sheet itself or any PM tool. Normally what happens when I said last time, I think in session 8 I was talking about that when I used to be a part of workshops for WBS. Similarly, some companies, they do day-long workshops to determine the activities, the dependencies, and they create activity list and all that. Okay, and definitely the project manager alone will not be doing this. He will need the help of the team, the key stakeholders also, sometimes from other teams, right? So let's go through some activities which are pretty much common. Like if you are a part of CIB day one project as a TPM, you will be knowing all this. If you are not a part of the day one projects of a TPM, that's fine. Just go through them and just have a look into the activity. So activity, when it is being planted, the list is being written down, then there is no then we are not keeping any kind of dependency on them. We are not thinking about it. We are just thinking, what are the activities? And that's the kind of the brainstorming which you do. So somebody will tell, okay, fine, we need to capture the requirements first. Then somebody will tell, okay, define, the design has to be done. We have to develop the design. Then we have to review and finalize the design. And then probably we also have to finalize the layouts of each of the floor on which we are going to plant, do the cabling or plant the APs and all that. Then we have to develop the bill of materials, which we have to share with the procurement team for the generation of the PO and the vendor suppliers. We also have to review the file and finalize the BOM. We also have to reach out to the vendors for the request for quote. So these are the different kind of the activities, but they are not in a sequence right now. I mean, you're just seeing them like the entire team has planted, and the PM also thinks, yes, these are the activities for one particular work package, or let's say start to finish for maybe the define part or the design part of the CIB. Day one project. Now, once you have figured out all the activities for that work package, then your next step will be to figure out what is the dependency between the activities. So when you look into activity A, like requirement capture, then it's fine. We can start it, right? That can be the beginning. Then B, when we talk about develop the design, now, in order to develop the design, you must have completed the requirement capture, right? So that's why we are telling in the third column, like the predecessor for B is A. Okay, so A must be completed for B to start, and we are talking about a mandatory dependency. Similarly, for C also, you will see that I have given B and F as the mandatory dependency. So B means the develop of the design has to be completed, and F is you also have to review and finalize the BOM before you review and finalize the design. Your design cannot be finalized prior to finalizing the bill of materials, right? So like that, all the sequencing has been done. And then once the sequencing has been done, then we are talking about the duration. How many days each will take? Again, this is not only the discretion of the PM, but the entire team has to agree that, okay, we can take like 20 days. Okay. timeline, then 30 days to develop design, 15 days to review and finalize. All that days has been plugged in by the team, because all the the key SMEs, they will be a part of this particular discussion, and they will all plug in the durations there. Okay, now this is the very first step which is done in the beginning of the schedule. Before even we talk about network diagrams and anything, we have to know what is, or what are the list of the complete activities to be completed, to be done, along with the dependencies between the activities and the duration of each of the activity. Okay. Now, once we are done with this, we are going to get into network diagram. Now, before I step into network diagrams and show you how exactly it looks like, in fact, we are going to do one, okay? But before we do that, we have to know a little bit of theoretical part here. Just one slide. I will not take it further, but this is very, very like critical, this slide, in perspective of the PMP exam. You definitely can expect some questions on this. So when we talk about the network diagrams, one of the most common technique to develop a network diagram is precedence diagramming method, or PDM. Okay. Now, which means that we have got, let's say, two boxes. I'm going to show you in the next slides, like how this kind of diagram or the network diagram looks like. Basically, two square boxes. One can be activity A and one is activity B. And then we also show how the relationship is between A and B. Okay. Now, when we talk about two activities, okay, then there can be four kinds of relation between these two activities. So think like there are two activities A and B which are sitting side by side. Now the first one, the most common relation between A and B can be finish to start, FS, the most common one. If you are kind of fluent with Workfront, you will be knowing that in Workfront the activities are finished to start, right? So which basically means that an activity must finish before the successor can start. So in our CIB stencils, most of the stencils are built on the assumption that an activity must finish before the successor can start. Okay. So basically in our case, the requirement capture has to be completed prior to the design phase can be kicked in, right? Here I'm telling the wall must be built before the painting starts. So that is finished to start, the most common one. Again, in the exam, if the logical relation between two activities is not given explicitly, then remember you are going to go with the default one, which is finished to start. The remaining three ones, they are used, and the last one is very, very rare. The second one is start to start. Start to start means an activity must start before the successor can start. Okay, so let's say that your coding has to start. Okay, now some companies say that a coding, the design must be completed and then the coding has to start. Some companies will say that no, the design can go till like 20 to 30%. Okay, and once the design reaches like 20 to 30%, then coding can start off in parallel from ground zero. We don't have to wait for the design to get completed, because at least we know a few modules of the design, and based on the modules, the coding team can start their coding. Okay, that is called start to start. Finish to finish is an activity must finish before the successor can finish. Okay, now this is the first one which I said in the previous slide. Like finish your coding before you can finish the testing. This is something like the old conventional rule that we are going to not start the testing in between the coding. We will finish the complete coding and then before you can finish the testing. So so this activity also has to finish. Like I cannot say my testing will be 100% completed if my coding is not completed, right? My coding also has to finish 100%. Even if the testing has started in between, the testing activity will only be 100% complete when the coding is complete, right? So activity must finish before the successor can finish. That is finish to finish. The last one is start to finish. It is rarely used. Personally, I've never ever seen this being used. It talks about an activity must start before the successor can finish. Okay. So remember again, once again, finish to start is the most common one, the most popular one, and PMP exam normally focuses on the first one itself, but if not explicitly mentioned, then always go with the first one, finish to start. So now we can get into develop network diagrams. So we already have seen a couple of things, right? Like the activity list, we have seen the dependencies, we also have seen the different kind of logics between activities. So this is how a network diagram looks like. Yeah, I know it looks like too much there, but it's very, very simple. Let me pull out annotation here. It will be very easy to explain, and then we can go from there. So network diagram, this is the start button and this is the finish, right? And in between this A, B, C, D, E, F, these all are the activities which we planted in the very first chart, if you remember. We told all the activities A, B, C, D, right? And we told that B has got a dependency on A. So you are starting A and then you have to go for B. You cannot start B till the time A is completed. Like your design part cannot be started before the requirements are captured, right? But there are certain items, if you look back into that chart again, then like let's say D and then E and then F, all these things are kind of can be done in parallel. They are not having the dependencies with A and B. Okay, and similarly, you will also see that your C and G, they are having a dependency on B and F as well. Let me go back to that. Okay, let's see how does it look like, and probably you will remember that. Um, One second. Clear all drawings. Let me take this off. Let me take you back to that particular chart and probably, yeah, this is the one I was talking, right? So you will see that your A is there and B is dependent on A, okay? And then your C is dependent on B and F. So this is B and this is F, okay? Similarly, if you look into the last part, like, your F and G, okay, this two are dependent on E and C respectively. So you have to keep this chart in front of you when you're drawing the network diagram. So refer this, probably take a screenshot, and then look into your network diagram. You will see what exactly how I'm trying to tell the story. I'm building a start button, and from there I'm taking, okay, what can be started right from the start button. Okay, so let me go back to that diagram and again pull up annotation. Okay, so that's all about the diagrams which I mean the activities which I formulated on this particular piece of paper, right? Or in the big board which I'm doing a brainstorming or a workshop with my team. Now you will see certain activities has to be done in the sequence which are dependent, like A, B, or C, G, and certain will be done in parallel. Like while you are doing A, you can definitely start off D as well. So there are two start paths, right? From two options we can start it. Now one of the reason we are developing the network diagram is, of course, to find out how much of duration each activity will take, how much of man hours each activity will take, and so on. The other reason is that we are trying to find out if we can put any buffer or float or slack. Okay, now on the right hand side bottom, I have shown you the network, the activity, that activity in detail, and we are just zooming into that. So activity box looks something like this. We call the PDM diagram method. Inside, we are giving out the activity name. It can be A, it can be anything. Let's say capture requirements. And the four corners of the activity box will be having four numbers to them. Okay, the first one, this is called early start, and this is called early finish. Top left, so left hand side is early start and right hand side is early finish. And this is late start and late finish. This is nothing but as the English, like the plain English, if I start early, then I finish early. If I start late, I finish late, right? Now the point is there is some concept called float. Float means late start minus early start or late finish minus early finish. Now float is also in plain English, float is called buffer. And sometimes the PMP exam will call float like slack. They both are the same, float or slack. And it means that the amount of time an activity can be delayed without delaying the project end date. So let's say my duration is like X amount of days. Let's say I delayed by 1 day, 2 day, 3 day, there is no impact on the day one, but I delayed by 10 days, there can be an impact on the day one. Now, what is that buffer that we can find out easily by looking into the network diagram? So that is all about the activity here. In inside the box, we are going to get the activity name, and outside we have got early start and then early finish, late start on left hand side, and right and late finish on the right hand side. And on the top of the activity box, we are going to get the activity duration, the number of hours or number of days the activity is going to get completed. Okay, so now let's run the show here and let me show you how this is done. So there are two ways to complete the duration or the network diagram. One is called the forward pass and one is called the backward pass. Basically, the two are joined or combined like together to find out the complete or all the details of an activity, like early start, early finish, late start, late finish. Okay, so first I will start the forward pass. Forward pass is nothing but when I'm starting my calculation from left and going towards right. Like I will start off my calculation from the start button, and then I will finish my calculation till I reach the end button. And then a similar kind of effort I will do in the next slide. I will call it backward pass, when I will start from the end button and come back to the start button. And let's see what is the fun that is going to be generated. Okay, so let's start the forward pass. So activity A, on this one, let's say the entire team agrees that, okay, this will take 20 working days to complete the activity A. It can be anything. In our case, it's the capture requirements, probably in your case something, but any kind of a sheet which you can pick up in front of yourself. Let's say activity A will take 20 days. B, the team says 30 days. C, 15 days. G is like 10 days. D, 20. E, 15. And F is 10 days. So that's the entire duration I got from the team. Okay, and certain tasks. So till now the network diagram is incomplete because I do not know what is the early start and what is the late start or late finish, or what is the float between the activities. So let's say I start off the forward pass from left to right. So I say for activity A, my early start is 0. So let's say activity A, if I start 1st of September, then my early start is 0 and my early finish will be 0 plus 20, that is 20th of September. Okay, or a little bit more than that because I'm only calculating the working days, but let's say all the days are working, then I will say 1st September I will start and I will finish in 20th September, right? So I'm telling 0 I will add in the as the early start, and I will just add the early start with the duration. 0 plus 20 is 20, and that will be my early finish. Okay. Now, when I go to activity B, remember your early start will be not 0, your early start will be 20. So whatever time you finished your A, that time will be your starting point of B. Why? Because we have told that A to B, the relation is finish to start, and also the dependency is mandatory. Unless and until PMP has explicitly told you in the exam, always consider that this is finish to start and the dependency will be mandatory. So you have to complete A prior to you start B. So A completes in 20th day and 20th day is the starting day of B, right? So what is the early finish of B? Easy calculation, 20 plus 30, that is 50, right? That's how we are going left to right, forward pass. Now let's come to activity C. So C, which is dependent on B, here the starting point will be 50. 50 plus 15 is 65, and we are getting 65 as the early finish. And wait, you might be feeling, hey, we have got F also as the dependency, like C has a dependency on F, and why are we not taking that 10 of F into consideration? We'll do that, but not right now. We'll do that when we are getting into the backward pass. Okay, and also when we are getting into that particular path. So we are just completing one path now, A, B, C, G, end. Then we will start with D, E, F, C, G, end. Okay, so 65 is the starting point for G, and the early finish for G is 65 plus 10, which is 75. Very simple Till now, I think it's very clear. That's called the forward pass. Okay. Now let's take this path, which is DEF. So again, for D also the starting point is 0 because that is right after start. Anything right after start will be starting from 0. And then 0 plus 20. For D, the early finish is 20. For E, the early start is 20. And for E, the early finish is 20 plus 15, 35. For F, the early start is 35. And 35 plus 10 is 45, which is the early finish for F. Okay. So that's how we got the numbers for the with the help of the forward pass. Now we have to do a backward pass to ensure that we get the bottom numbers. Let's see how we do that. So again, a different slide, but we have got all the numbers already added, which we have done in the forward pass. Now we are going to do the backward pass to get the complete information of the activities. So this time, backward pass, as I told you, that we will start from right to left. So we will start from the end button and we will go towards the start button. So let's talk about activity G, or let's talk about the end button. From there we will start. So here, look at the end button. Activity G, we are going to calculate the late finish. What is the late finish here? We'll take it 75 because that stage is the end stage, right? So whatever will be the early finish, that will be the late finish for the last piece of the activity, right? They both will be same. So we are taking 75. Now what we are going to do, we have to find out the late start. So late start will be here 75 minus 10. So minus 10 is 65. So we are taking the late start also 65. Now looking at this activity, can you tell me the float or the slack or the buffer now? It is 0. Why? Because the formula is late start minus early start, which is 65 minus 65, or late finish minus early finish, which is 75 minus 75. The buffer is 0. So we do not have any single day in the activity apart from this exact 10 days. If we delay even one day there, we are going to miss the end date. So there is no buffer, it's 0 here. Let's talk about then C. Here C, the late finish will be 65 again. Okay, we are just going backward, right? So 65 you punch in there, and then we will say 65 minus 15, which is 50 for C as well. Okay. Going forward, we will again hit this item, which is item F here. Here we are taking 50 here. So 50 is the late finish, and 50 minus 10 is 40 is the the late start, right? So late finish for activity E will be 40. Okay, we are taking this, I mean, just going backward, and 40 minus 15, which is 25, which is the late start. Similarly, here, late finish for D, the starting point will be 25, and 25 minus 20, which is 5. Now, 25 minus 20 is 5, that is the late start. Now, what does it mean? So if I look into item G, I am seeing that I don't have a buffer because this late start minus early start, like 65 minus 65 is 0. Similarly, late finish minus early finish, like 75 minus 75 is 0. There is no buffer. But when I look into activity D, then I see that late start minus early start, which is 5 minus 0, is 5. Similarly, late finish minus early finish, which is 25 minus 20, which is also 5. That means that if I start the project on day 0, let's say September 1st, then I will finish the project on 20th of September. And if I start the project on 5th of September, which is late start, let's say for some reason I start the project late, not the project, but the activity late, then I will finish this activity on 25th of September. But till 25th, I have got the buffer. Okay, I mean, even if I complete this activity by 25th of September, then also I can hit the end date because I have got a buffer. I mean, I have got a buffer of 5 days there. The float is 5, which means I can play with 5 days. I have got a buffer of 5 days. And these are the things which you should keep when you are dealing with your external dependencies. Let's say custom or some kind of federal approvals you're waiting. Those kind of things you should always keep a minimum amount of a buffer, not a big one like a gold plating or padding, because gold plating or padding is strictly not recommended for PMP. So gold plating or padding means that you are keeping unnecessarily, too many, buffers or too much of extra cost and all that stuff or contingency there. We will keep minimum, but that minimum buffer has to be done. That is the benefit. So activities which are having external dependencies, those cases you definitely have to keep a little bit of buffer, and any smart project manager will be doing that, right? So activity D has got a buffer. Now let's go back to the path of A and B. So for B, the late finish will be 50, right? That's what is the late start for C. So late start of C will be the late finish for B, right? And then the late start for B will be 50 minus 30, which is 20, right? Similarly, late finish for A will be 20, and late start for A also is 20 minus 20 is 0. So again, for A, you will see that there is no buffer, because if I subtract the late start minus early start, 0 minus 0, or late finish minus early finish, which is 20 minus 20, I get A, the buffer is 0. The float is 0. I cannot delay A at all. I don't have any way to delay. My early start is September 1st, and I'm finishing on 20th of that same month. And my late start also is September 1st, and I'm finishing on 20th of September. So I don't have any concept of actually a late start there. I mean, I cannot delay this activity by a single day. I have to finish it on time. This is what I call a critical activity. And I'm not going to again share the definition of a critical path right now. We'll keep it for the next lesson, like lesson 10. That will be too much to absorb in this a single one or single session for the time, right? So we have done a lot here, but my aim was to show you that this is what a network diagram is. This is what the network diagram can do for you. You will know the duration of each of the activity. You will know the sequence. You will know the dependency, and you will also know the early start, late start, early finish, late finish, and definitely at the end of the game, you will know the float or the slack for each of the activities. Like how much can you delay, or how much delay can happen without impacting the end date of the project. Okay. Now, based on this, we are going to find out the critical path that I'm going to share in the lesson 10. Like I said, it will be too much to absorb in, all the stuff of the schedule in one single session, right? Okay. Now, like I said, everything of this concept can be done in a standard project management tool, let's say a Microsoft project. Okay, very nicely it will do it for you. But it is expected that a project manager, especially a PMP certified project manager, should be able to develop a network diagram on their own. So the exam questions will be something like this. Let me share it with you quickly, how the exam will look like. Sorry, I just went forward. Probably I have to just exit from there. The exam, we are going to do some questions also, but the exam questions will be something like this. Uh, they will not give you this activity list. What they will tell you is that activity A starts, and then B and C are dependent on A, and then E and F are dependent on B. Like that, they will give you some statements, and you immediately have to draw the start button and follow those statements and draw a diagram, like which are like dependent, which are non-dependent, which are in sequence, which are in parallel. Once you draw the network diagram, they will actually give a sheet to you, and they will give you the duration of each of the activities. And then you have to plug in all the activity, the durations there, and you have to just go through that entire list with a forward pass and a backward pass, and you will find the float, and then you will find the critical path. So the questions in the exam will be that, what is the critical path? Looking at this particular activity list. So it is not difficult at all. I mean, in fact, it's very easy and very fun. But the more you practice, the more easy for you, because there are certain tricks and steps there which you have to know it, and that all will come with practice. Okay, so we'll come to that. We'll practice a few questions on this. At the end of the schedule baseline, I can take you through one or two like questions, and we can solve it like together. But the point here is that uh, getting marks in schedule, in cost, is very easy, because schedule and cost are the two concepts where it's completely mathematics. It's nothing to do with human behavior, which is more of those cases will be coming in stakeholder management. Okay, it's a like a mixture of science and art. But schedule, cost, these are the areas where you should be absolutely fluent, because those marks will be solid marks which you get. There is no second, there should not be a second thought in your mind, because these are all mathematically driven stuff, right? The only thing which is being done in a PM tool is that on the back end, these algorithms are placed, the coding is done. So the moment you put the data there, the software will automatically generate the network diagram along with the critical path for you. Okay, so with that, we come to the end of the lesson 9, and also we have done a good amount of the portion of the schedule piece. We are going to do at least one, or probably I will say two more sessions on schedule, and then we will keep some time to solve a few of the problems, a few of the mathematical problems I'm talking about. And I will encourage you strongly that practice this as much as possible. This may not be your day-to-day job. You may not be doing a network diagram every day, but the more you are well versed into that, more you understand the concept. You take time in the beginning, you take like 30 minutes of time in the beginning to solve one network diagram. That's okay, that's fine. But the more you practice, that 30 minutes has to be compressed and brought down to maybe 2 minutes, or maybe 2.5 minutes and all that, not more than that. Okay, because in exam there will be multiple questions. I think 180 plus questions are there, and you get only 4 hours to do it. I mean, it sounds like 4 hours, but if you calculate that, you hardly get some 1 minute few seconds to finish each of the question, right? So we'll come to that in detail, how to time manage from the exam perspective. So we are now deep into project management. If you think this is too much for you, take a break. Again, start from the beginning, go through the parts which I explained, starting from the fundamentals of project, then groups and processes, different knowledge areas, and then we started with scope, and finally we have got into schedule, right? A lot more to go. But trust me, once you finish the planning stage, uh, with schedule, scope, scope, schedule, cost, budget, and then get into communication management and quality and stakeholder and all that is done, you will not be left with too much of stuff to really crack on. I mean, uh, I will show. I will go through the entire blueprint, but trust me, this is the main, the main crux of the PMP exam. Okay, the first thing is milestones. Now, looking at the activity list and the network diagrams, many people, many of you probably will be doing this, and many people do that. They will say, okay, that is milestone 1. Once you complete activity 1 and 2, it is milestone 1. Correct, fine. Once we are like in a normal infrastructure project, there are 5 to 6 standard milestones, and we call them, like, first one is define, then we have got design, third one is order hardware, fourth one is getting into the implementation stage, fifth is testing, and sixth is go live, right? I mean, normally most of the day one projects, they go through this flow. Now, it is absolutely fine, and also I will say good to have milestones for each of this. Like define is a milestone, then design is a milestone, then order hardware is a milestone. Like that, you can have 5 or 6 milestones planted in your delivery timeline. Absolutely fine. It's a great approach. But what you should not do is that you should be knowing what exactly is the definition of a milestone. So milestones are nothing but they are significant events within the project schedule. That is all. They are significant events in the project schedule, and that they are nothing more than that or nothing less than that. The point is, they are not work activities, and they have got no duration. Just remember it. So when in the exam you get the question, you will not get a direct question like this, but know this, that what is the duration of a milestone? Your answer will be 0. A milestone do not have any duration. Milestones are durationless. They are just a kind of a flag, a kind of a marker that, okay, we have achieved so much of task, maybe 30% of the project is achieved. So we have reached the milestone 1, which is great. But milestone 1 is equal to 45 hours of work. That is absolutely wrong approach. A milestone is having no duration. Okay. Second point is the dependencies. So dependencies, we have gone through them so far, and there are four types. One is mandatory or hard logic, then discretionary or soft logic or the preferred method, and finally we have got external and internal. And lastly, float or slack. Very important concept. Just remember that is buffer. Okay. So float is the amount of time an activity can be delayed within a project without delaying the project end date. Right. The end date, there is no impact. I mean, until and unless you have got a float. If the float is zero, then you cannot play with that activity. That means you have to do it as per the schedule there, or else it's a hit on your project end date. And that is the clue to your critical path definition, which I will come to in detail in the next lesson. All right. With that, we came to the end of the lesson 9. Thank you all for watching this. I hope you enjoyed this video. Wish you all a great day and a great time. Thanks.